Hello everyone, so welcome to the second video of this HLD playlist, and in this video we are going to study about the advanced topics of TinyURL. Before heading towards this video, I just wanted to say please watch the first video because that will just set up a base for you, and without wasting any time, let's get started and study TinyURL. So the first point that we are going to cover, in the last video we have discussed about this design, and I already told you that we didn't discuss about the databases. So first of all, we are going to start with our database. So here we are going to discuss what are the data that we are going to store in our table. So it is going to be pretty simple. We are going to store our first column is going to be TinyURL, where that we are going to make our actual URL, our created at, expiry at, and our clicked. We didn't study expiry at and clicked as well. Now we are going to discuss them. So this TinyURL column is going to be unique, and it should be unique because we cannot store the corrupt data in our database. Secondly, we have to index it. The data should be indexed because as we are going to make it index, the searching is going to be pretty fast. If we are going to use a MySQL DB, then the indexing that is used by the MySQL, it is B tree, and then the searching is going to be in O of log n instead of O of n. The data is not going to be search in every single row. What MySQL do, it stores the data in a sorted order so that it makes the searching a little bit faster. Now moving forward, let's discuss about the database choices. So we can we can take NoSQL as well. We can take relational database. We can take non-relational database. So there is a whole argument about it. But in our scenario, we are just simply taking the MySQL. Reason being, we don't have any complex structures. We don't have very hard documents that we have to store in our database. We can just simply go with the MySQL. You can also see some videos where you can say that it's very easy to scale non-relational database. There can be a whole video that which database to be choose in this scenario. We can simply take MySQL as well. Reason is that what I wrote it down. First of all, that we need searching that is provided by the indexing that I mentioned in the MySQL. Second is, what about partitioning? We already told you that in the last video that we are going to use a B62 hash function. Okay, so if we are going to use a hash, we already know that the hash is already present in our system. So we can do a partitioning with the same hash of the database. We already know the hash string, so we can do the partitioning of our database with the same hash. So it will be very easy and makes the search very fast, because suppose if we make a TinyURL with the same hash and we make a partition with the same hash, then we simply know that the data is going to lie in the first database or the second database. It makes the things pretty simple. Now the third point is single leader replication. Suppose there is one leader, so it means that every write operation is going to happen on the leader, and there are followers. The follower are going to get in sync with the leader. This is something called single leader replication that is also provided by the MySQL. So these are the reasons that we are using, that I am using MySQL right now. But you can study more, that there can be a possible solution with the non-relational database, and you can also use that. You feel you are free to do it. Now in this replication, there are two techniques. Okay, they are important two techniques, that is synchronous replication and asynchronous replication. So what you mean by synchronous and asynchronous? In the synchronous one, what will happen? Whenever you will write into a leader, you will also write into a follower in the synchronous one. So what will it give you? It will make the system consistent in that time, but the response time will increase because it is going to write in all the followers as well, and then it is going to give you the data. It is slow but consistent. Second one is that you are just going to write into a leader and it will return you the response, and then it will connect to the follower and update the follower. It will sync with the followers. Now in that situation, our write is going to be very fast as compared to synchronous one, but the data is going to be inconsistent. But remember one thing, the data is going to be consistent after some time, but it is going to be inconsistent for very little time. Can we handle it? This is the point. Suppose if you generate a TinyURL, so who is going to if you are going to send the URL to another person, it will take up to 2 minutes or 3 minutes, and of course then the 2 or 3 minutes all the followers are going to be in sync with the leader. Okay, so can we take this inconsistency in our system? Okay, so this is the question, and maybe like we have these two approaches and we can go with any one of this. If you can take the slow read, then you can go with the synchronous one, and if you can take the inconsistency of little bit of like 10 seconds or 5 seconds, then of course you can go with the asynchronous one. Up to you. I'm going with the asynchronous one right now. We need fast system, so I already told you that go for asynchronous leader replication. Now we have to change a code logic in the asynchronous one. Like suppose we want to solve this problem for 5 seconds as well. So first of all, we are going to search in our Redis. Of course, we are going to update the Redis. So first of all, we are going to update the Redis. Then we are going to search into our follower DB. Like if it has the updated value, and if didn't have the updated value, we will going to search into a leader database as well. And then we are going to say that the particular URL exists or not. So this is something that we can do with the asynchronous leader application. We have to write our own logic in the code. Now moves to the second point, that is caching, that we didn't discuss in the last video. Let's talk about it. When we started this whole tiny URL thing, I told you that there are clicks and there are some URLs that are going to have clicks from range 10k to 1000k. So do we need to cache all the URLs in our system? So suppose there is a URL that has the clicks of 10,000 and there is a URL that has a click of 1. So do we need to store all the things in our caching? So this is an important point. This I want you to think about it. Like, do we need to store all the URLs in our Redis or any cache that we are using? So now moving forward. So now we have 3 algorithms for caching that we are going to discuss. So first of all is write back. So it is saying that first of all we are going to write into the cache, and then we are going to write into a database, and then we are going to return our output. It is a slow algorithm because it is using the two-phase commit. We are writing into a cache, then we are writing into a database, and then we are returning. Second one is write through. We are writing into a database and then we are writing into a cache, and it is of course a two-phase commit, and it is also a slow process because we have to write in both the places. Now comes to a solution, that is write around. So what is write around? Write around says first of all put into a database, then database is put into a Redis. Okay, and this, when the data is going to put into a Redis, it is going to a asynchronous operation, not into a sync. So whenever you put into a database, it will just return you a value, and then a new thread will open that will put a data into a Redis, and you will just got a result. So again, I ask you the question when we started the caching point, that which data to put in Redis. So do we have to put all the data into a Redis, or do we need some sort of thing like what data to put in Redis? If we put all the data into a Redis, we are already storing that data into our database. So we need some algorithm in Redis as well. So what we can do, we can use the least recently used in Redis. So if the URL is not used for a long time, we can just simply remove it and we can just update a new URL in it. So this is something that we can do in our Redis. So finally, we reach the point where we are going to study clicking. So clicking means that we need a incremental counter every single time when we clicked on a tiny URL, the counter should increase in our database. It will help the companies to analyze which URL has been clicked more and something like that. Okay, so now what we want to do, so we have discussed this database and we need to increase this counter every single time the URL has been clicked. How we can do it? So first of all, I wrote it down here. Do we have to use locking, or will it slows down the system? So what do I mean by the locking? So suppose if there is a row contain a value 100, and if we lock that particular row, whenever the row is going to update, then it will ensure that like suppose 100, then it is going to be 101, then 102. But assume that on a single second, 10,000 people, 20,000 people, or 20 lakh people simply make click on that URL. What will happen in that scenario? 20 lakh request of updating the database will come, and there is a lock on that row, and they are going to be in a queue and they are going to process the data. Okay, so will it slow down the data? This is the question. Secondly, if we don't lock, okay, there will be a problem of dirty read in that scenario. So suppose the value is 100 and one wants to change it to 101, and like there is another person, like suppose A1 wants to change it to 101 and A2 has to change it to 101 to 102. In that scenario, what will happen? If A2 made a dirty read of 100, then it will also update it to 101. So there will be data inconsistency in this scenario. That locking. Now we know that we cannot use locking, and there will be a problem of data inconsistency. Then what will be the best solution? Before reaching to the best solution, I will give you one more problem statement of solving this clicking. Okay, please, I want you to focus and understand this problem as well. Suppose there is a guy as a delivery partner of from Zomato coming to my home for delivering the food, and every single second he is changing his location. Like his latitude and longitude is changing every single second. Every point of time his location is changing, and it is going to update on my phone, and it is also going to save in some Zomato's database as well. So are they storing every single point of that user? It is like necessary for Zomato or not? Like for every single second they are storing the data. Like it is a lot of data. Are they storing it? Okay, this is the question, and I want you to think about it. Like, do we need it? Okay, do they need it? Okay, and if they are storing it, and like where they are storing it, and how they are using it. Like think all of these questions, and maybe you will like figure out something. Now, like let me just come back to the topic and let's understand how we can solve this problem. That is, we can solve this problem with the help of the streaming process. So what we are going to do in this scenario, we are going to put, like if there are 10,000 requests, what we are going to do, we are just going to put the data somewhere, and then we are going to aggregate them in like we are just going to aggregate them later. So what we are going to do, like suppose the count is 100, and after that in next 10 seconds there are 20 lakh requests. So we are not going to directly make 20 lakh DB calls to our database. We are just going to simply make all this 20 lakh requests in our some sort of another database or some sort of a queue, and then we are going to aggregate all of them, and after 10 seconds we'll just make a single DB call to update our count from 10,000 to like 10,000. The count was 10,000 then plus 20 lakh. This is something that we are going to do. How we can do it? So there can be multiple solutions. We can use queue, or we can use a time series database logic. Let me just make it with a diagram for you. So suppose there is a click. Okay, instead of like it is making a request to a file like server called A1, and one service is going to return it a long URL. They're hitting with a tiny URL. They're clicking on it. The request will come to A1. Enable will call go to Redis, and it will return a long URL to the users. This is the first operation. But in the second operation, we need to increment the clicks. So for this, what we are going to do, it is going to be simple. We are going to put the request in a queue. We can just say Kafka, or we can just simply put it into any log based queue, or in a time series database. We are just going to store all the requests. After that, when we store all the requests, either we can use a Flink, or either we can use Flink, or either we can use a write down a custom logic that figures out how many requests did we get in the last 10 seconds. And as we figure this out with the help of the Flink or with any custom logic, we are just going to make a single write call to our database in every 10 seconds or in every 20 seconds, that this is the increment counter that we computed, and then simply put it into our database. This is the best way to do it. I'm very tired after like I'm speaking for so long. Now comes to the next point, like we have to delete the expiry link. So if we have to delete it from the cache, so we like cache has already have a feature of TTL, so we can simply use it. But now we have to delete it from our databases. So we can run a cron job also. That will the cron job will do. If the current time is greater than the expiry time, then we can simply delete it from the database. In the Redis, we can also delete it from the Redis, and but Redis also have the feature of TTL, so we can delete it with the help of that. Or otherwise, you can just use this logic as well. Now come to the final design of a tiny URL. That is the good design. We studied a smaller version of it. Now we are going to see a larger design of a tiny URL. So this is it. It looks little messy, but I hope you will understand it. First of all, let's understand it with the help of a post person or the guy who is going to write the URL in our system. So first of all, the request will come to the load balancer. Then the load balancer will send the request to the A1, A2 or A3, any of the system, doesn't matter. These service will communicate with the zookeeper that we have discussed it, and the zookeeper will give you a bucket counter which you can generate a tiny URL. Then it will go and store into our database. The database are going to be partitioned that we have discussed, that we are going to use the same hashing algorithm by which we are going to which we are going to make a tiny URL, and with the same hash algorithm we are going to partition our database. After partitioning our database, we are going to put the data in our partitioned Redis. Okay, so this hashing algorithm, can you see, is helping us in creating the URL, helping us in creating the partitioning the database, helping us in partitioning the Redis as well. So we exactly know where is our correct data. This is something that we are going to do at the time of the write. Now what will happen when there is a read call comes? Read call will come to our load balancer. Load balancer will call the service A1, A2 and A3. Then this A1, A2 and A3 service are going to look our data into our partition Redis. As they are going to get this data in our partition Redis, what will they do? They will simply return the data to the load balancer, and then the user will get the URL. Now, there is a point that we have discussed now. Whenever there is a call to any of this service A1, A2 and A3, there will be a process that will start, that these services will put the data into a Kafka queue with some sort of a counter or with some metadata. Let me just put it down one here, that they are just going to send one into a Kafka. Then this data will reach to some new service, or like a streaming service, or we can say a Flink service, or a custom logic that we can create. Whenever we received 100 calls, okay, we are just going to put it into our database, and we'll increase the count by 100, or we will say after some time, like if the request came for 30 and there are no requests after that, we can just simply put it into our database. We can just write it down a custom logic or any service that we can use like Flink. Okay, so this is something, a complete tiny URL design. So now I'm completely tired after making this whole diagram. So thank you for watching me till now. I want you to pat your back if you are still here with me, and I will provide the whole PDF of it, and I want you to study more. And thank you for watching me till now, and let's meet in some another video where we're going to study more about high level designs. And till that time, bye bye.